So today I'm back again with a Leetcode problem. So the problem is of 7th, not 7th, but 6th of October 2020. That is 701th problem, and the problem topic is insert into a binary search tree. So the problem statement that is given is you are given, let me show you. Yes, you are given the root node of a binary search tree, and along with that you are given a value as well that to be inserted into the tree. So basically you are given a binary search tree and a value that to be inserted into the given BST. Now what you have to return? So you have to return the root node of the BST after the insertion of that value that is given. Okay, now it is said that it is guaranteed that the new value does not exist in the original BST. So the value that is given to you that to be inserted is not already present in that given BST. Okay, and the notice is given that there could be a multiple ways of insertion into a BST, so you can take care of that. So anyway, now let me explain you the problem with the help of the example that is given with the problem. So first of all, we have to understand what is a BST. Well, a BST is different from a B binary tree. What is the difference? So in BST we insert each nodes with some rule. And what is the rule? Well, every parent node's left child will be less than the parent node, and every parent node's right child will be greater than the parent. So if I could show you in here, that is a given BST. The parent is 4. Well, the left of 4, all the children that is left of the 4 will be less. That we can see, like 2, 1, 3 all are less than 4. And on the other hand, all the children that are present on the right side of the parent will be greater than 4, that is 7. Okay, now that is true for all the nodes. Okay, so if I consider this, let me show you this 2 as a parent node, then all the nodes of the left of 2 will be less than 2. Well, that in this case is 1. Well, this is less than 2, and all the nodes of the right of the parent will be greater than 2. That we can see. So that is a BST basically. Okay, all the left node of all the basically left children of a parent node will be less than the parent value, and all the right child or children of the parent node will be greater than the parent node. Now, well, we are given a BST. Now what we have to do is we are also given a value that to be inserted in a BST. Now let me show you here, that is input. Well, in input we are given root, that is good, and along with that we are given a value that to be inserted is 5. Now the thing is that it is not a binary tree. We cannot insert the 5 anywhere we want in a tree. No, we have to obey the rule of BST insertion, because we have to maintain the BST property of the tree as well. So how do we do that? Well, there is a rule. What? As I told you earlier, that every left node of a parent node will be less than the parent node value, and every right children of the parent node will be greater than the parent node value. So let's say if I could show you in the original binary tree, where will we insert 5? Well, we will check for the nodes. Now 5 is less than 4 or greater than 4. 5 is obviously greater than 4, then we will go to the right. Okay, now we come to the 7th node. A 7th node, not but a node with 7 value 7. Okay, now we will check again. What? Well, if 5 is less than 7 or greater than 7, obviously 5 is less than 7, so we will go to the left of 7. Well, now we don't have any node in the left, so what we will do, we will simply insert the 5. Okay, we will simply insert the 5, and that is the solution that is also shown in here. Okay, so that we will do. Now what will be the principle of solving the problem? Well, we are doing one thing again and again. What is that thing? We are checking with nodes that whether it is less than or greater than the given node. Okay, so in this case what we could do is we can use recursion, because we are doing same thing again and again. But now what will be the base case of the recursion? Because we need to have a base case, that is mandatory in recursive solutions. Well, the base case will be when the root would be null. Okay, let's say in this case we go to first 4, from 4 to we go to 7, and from 7 we go to the left of 7, but the left of 7 is null, we don't have any node, so that will be the base case. And when we find the null, what we will do, we will create a node and insert the node, whether it is on the right of the node or on the left of the node. Well, in this case it will be on the left of the 7. Okay, so let me first, what we will return? Well, we will return root at the end. So I wrote it earlier because we are returning the root. Now first we will check for the base case. Well, the base case is when the root will be null. What we will do, we will create a node. Well, now I am solving the problem in C++, so that is a thing that you have to take care of. Well, the algorithm will be same, you can solve it in any language that you prefer. I am going with C++. Well, so if root is null, what did I say? We will create a node. Okay, how would we create the node? Well, in C++, what we do, first we type the name of the struct, that is tree node. Okay, and we will create a new node. I am naming the new node as new underscore node. How would we do that? Just type new and the name of the struct, that is node, parenthesis. Okay, now we have successfully created the node. What we'll do now, we will assign the value in the value part of the new node. Well, what will be the value then? The value will be that what is given to us. Okay, in this case the value is 5. Okay, so we will assign the value to the new node's value part, and after that we will simply return the new node. Okay, now that was our base case. Now what the recursive condition? Well, we will have two cases. When the node when the value that is given is less than the root value or greater than the root value. So what we'll do, if the root value is greater than the, or we can simply type in any way we can type, we can just say if the value is greater than root well. Okay, what we'll do, well, we will simply go to the right, because if the value is greater than the root value, then we have to go to right. So we will call the recursive statement as insert into, we'll call the again that insert into BST function, but this time with root right as the address, and the value will be the same. But what we'll have to do, we have to store the value as well, because let's say in base condition we are returning a new node, so we have to insert that new node somewhere, na? So where will we store? Well, if the value is greater, then we will store it to the right, and if the value is less than that, we will type in a few seconds, we will store it in left. But for the right, for the value, if the value is greater, we will store it to the right. So just root right equals to insert into BST root right and into value. And else if value is less than root value, then what we'll do, there is one mistake that I made. We don't have to we don't need to type int. Okay, now if the value that is given is less than the root value, then what we'll do, then we will go to the left. Okay, and if we are going to left, we'll store the value to the left that we will get from the base case. Okay, so we'll simply type insert root left equals to insert into BST root left well. Okay, now if we run the code, let's see what happens. Well, it is being accepted. Good. Now if we submit the code, let's see what happens. Well, I have submitted the code 2 times earlier as well. So it says that took 132 milliseconds. That is quite good, faster than 41.83% of C++ online submission. Good. And 59.9 MB is taken as memory usage. Well, that is quite good. So that's how we solve the problem, that is insert into the BST. Okay, now again if I summarize this, what we are doing, we are traversing the tree. What we are doing is, well, if the given value is greater than the root, we will go to the right, and if the given value is less than the root, we will go to the left. That is the principle of a binary search tree. Okay, so that's how we solve the problem. And in these cases we are maintaining a base condition that when we find the root equals to null. So if we find the root equals to null, we will create a new node and then return the new node. And to accept those that returned new node, we will store those recursive problems into root right and root left. Okay, and at the end we are returning the root. So I hope you would have understood this insert into BST problem. Okay, and if you did, if you liked the video, don't forget to give it a thumbs up, and also consider subscribing to the channel, because I will be putting these type of videos and also development related videos on this development squad channel. So this was me, Aman, signing off.